Hello, everybody, and welcome back to episode number 34 here in the Happy Space Prison. Today, we're going to be working on advancing our rocketry program into the hydrogen and liquid oxygen state so that we can make hydrogen engine rockets that can take us all the way to the end of the star map. Before we get into doing that, one quick change I want to make is we can automate our rockets. And because we have our rockets already fueled and things set up like that, there's only two things we need to do to automate our rockets. And that is we need to connect an automation wire from here to here. That's going to make it so that when the rocket says that it's ready to go, it will just send a green signal down one block to the launch command to say it can launch. In order to make it so that that can be done without me getting involved at all, I also just need to connect some shipping rails over here. And we're going to just have them go down here. And we're going to do some more here. And put in a conveyor chute. And all that's going to do is when the rockets land, all of our materials that are in these cargo bays are going to get shipped out. And as soon as they're empty and the fuels are refueled, it will tell the command capsule that it's ready to go, and it'll relaunch it so that we can let that keep going while we get working on liquid hydrogen and liquid oxygen. Before we get started on our main focus of making liquid hydrogen today, we need to address some supercooling stuff now that we have access to it. First of all, we got this achievement. Let's go check that out. Not okay, but pretty cool. It's reduced the temperature of a building to 6 Kelvin. I actually got it during the last episode, but sometimes that achievement doesn't register until you restart the game. So it popped up when we got back. That was for running our supercoolant up here in our new system in these buildings. These buildings actually got so cold that they are saying liquid too cold to cool any further. And so the buildings that they are cooling are in the sub-zero temperature ranges. So that's up here. The robo miners are minus 271. So they are at absolute zero. What we're going to work on right now is I want to replace these power-hungry cooling systems down here. We have systems that are trying to keep up with the runaway temperatures from in here. And in order to do that, they're running through and cooling down petroleum 4 times, and it's using tons and tons of power, which isn't a problem because I have tons and tons of power. But with supercoolant, I can do the same thing with just one, and it will work very efficiently, and it'll get it much colder without nearly as much work. So we need to get some more supercoolant. We need to get it moved to where we need to, and we need to flush out the petroleum in the lines. I think I've already pointed this out, but I really do like the small touch of them changing it so you can actually see what fluid is running through a machine. This aqua tuner you can see has supercoolant running through it, whereas these over here still have petroleum running through, and you can see that visually. And it's a minor touch, and this one's still petroleum, but it's really cool, and I like it. This one is now running. I have a tank up here with supercoolant in it, just a small amount, so that we can have a little bit of a buffer, and we have our loop running up here and cooling down all 10 of these steam turbines, so they're running efficiently, and they are cooling down very quickly. They were struggling just to keep them at operating temperatures before, and now we are very quickly going down to very cold temperatures. We can actually set this to go, let's go to minus 200. I don't want to set it all the way down because we have hydrogen gas in here. Hydrogen gas would freeze at minus 252. So if I were to set this to all the way down, then this hydrogen would turn into liquid hydrogen, which we do want to do in this episode, but not in this area. So we're going to let that keep running. I'm also going to swap out this side, but you can see this one is running one aqua tuner with supercoolant. And because of the efficiency of the supercoolant, we can do it with very little power compared to this power-hungry machine over on this side. So we're going to swap that out. This is the coolant that cools down this area up here, and we can do the same thing there. All right, we've gotten our other section of supercoolant swapped out. We still have some other supercoolant or petroleum loops that are being used for coolant, like this one here. And eventually we can swap them out for supercoolant as well. And then I have some that are in places like our volcano tamers and things like that. Switching them to supercoolant would certainly help make them more efficient and make them work better. But they've been working fine with petroleum, and they're not using a ton of power, so it's fine. These two were just really drawing the power from my base. So getting rid of these big power sinks will make it so that our power will run even more efficiently. But we're done with that for now. We're not going to focus on this anymore today. We're going to get on with working on our hydrogen and oxygen setup. And you can see our rockets are handling things just fine. They're coming in. They're going to unload the things that we have gotten. We keep getting more and more of these artifacts as we go, but you can see the items are being offloaded quickly. And by the time we get the cargo bays unloaded, we'll have the fuel and the oxidizer reloaded, and the rocket will just take off again and go for another trip. So we can just keep building up our supplies of things like fullerene and supercoolant and thermium, and we'll be all set to do some pretty cool stuff. But for this setup, we need to get working on running some of these loops. We have the coolant in here. It's already being chilled down because we've been running it. This one I actually don't think I've been looping it. Let's see. There, now we can have it working on getting things cleared up, or cooled down, I should say. This one has been running for a while, so it's already done, so we have it ready to go for our hydrogen setup. We're going to set up right in this area here to do the liquid hydrogen and the liquid oxygen. In order to make liquid hydrogen and liquid oxygen, all we need to do is take the gas and put it in and cool it down to a temperature where it turns into a liquid. It gets a little more complicated than that, but that's basically what we're doing. And with supercoolant, we can go that cool because supercoolant can go down to minus 272. So with hydrogen, we need to get it to cool down. To turn it into a liquid, we need to go below 252.2. And of course, there's an extra 3 degrees needed there to push it beyond that because it is there is a variance there. The problem with hydrogen is that there is a very narrow window from when hydrogen gas freezes into liquid hydrogen, and then from when liquid hydrogen freezes into solid hydrogen. So the gap we have, so we have to get it below 252.2 to turn it into a liquid, and we need to keep it between there and 259.2, well, 262.2 before it'll switch into a solid. It's only a 10-degree window, which means we need some pretty precise control on our temperature. Fortunately, we know how to do that. So basically, all we're going to do is we're going to have a room where we will have hydrogen gas pumped in, and we'll have some automation to continue cooling it and keep it at 200, between that range of 255.2 and 259.2, so that it stays in the liquid state. And then we'll be able to take it out and feed it into a rocket. For our oxygen, here we have some oxygen. We can look at it right here. We have a slightly better window. So let's pull up liquid oxygen. At the variance between liquid oxygen or from gaseous oxygen to liquid oxygen is at minus 183, and then it doesn't go to a solid until minus 218. So it's a bit higher of a temperature, and there's a much bigger range in there for us to hit the target. So it's a little bit easier to do, but the process is the same. So we're going to get 2 areas set up here where we can pump in the gases, turn them to liquids, and then pump them out to go to our hydrogen rockets, which we're going to be putting in this area up here. So a lot of challenges to tackle in that area, but nothing that we don't have the tech to do. Done just a little more prep work, and we're ready to get started on our hydrogen and oxygen systems. So first of all, I built a rocket. This rocket, I used the Professor Oakshell calculator just to figure everything out. This will be a design that we can use for any of the star map destinations. So all the way from down here all the way up to the top, and even for the temporal tear. The only difference is if we are using the temporal tear, we have to take the cargo bay off because it'll be a little bit too heavy to push that final distance. And for the earlier, the shorter distances that we're doing, the less fuel tanks that we need. So we only ever need 1 oxidizer tank, and we need anywhere between enough fuel to go into 1 up to 4 tanks. So I just built it this way so I can see the maximum size rocket that we're ever going to have for any of our star map destination. And I went through each one and checked. We could just leave it like this and have empty fuel tanks, the extra weight will mean that we need a little bit extra fuel, but it's not much. The reason I did that is because I wanted to see where our refueling points are going to line up. So we have liquid oxygen that's going to have to go down to this point, and these 4 points are going to need to be set up so that they can receive liquid hydrogen. So that's all set and ready to go. I also ran some oxygen and hydrogen up from the bottom of the map, though now that I started building, I kind of wish I had switched these two lines. I might change that later. But basically, the hydrogen is just being pulled off of our main line. I actually want to redo that. I didn't finish converting everything to insulated pipes. The oxygen comes from over here. I ran some new power lines and kind of cleaned everything up in here. This area has enough space for us to have 16 gas pumps in it. I've never reached that many. I just put in a few more. 16 is because if this is running at 100%, all 9 of these, 16 gas pumps is what you need to empty the oxygen out. I'm never going to be using that much oxygen. This build was designed to be way, way more than I need. And in fact, right now we're sitting on 42 million grams of oxygen per tile. Like I don't think I'll ever use all this oxygen up. But we are pulling oxygen out, and I'm cleaning up these lines a little bit just to get them a little more organized here. So let's finish these up here real quick. Basically, I have switched over to this more streamlined design where I use a bridge so that I can have it all in one line instead of having 2 lines taken up. And so we just cut that out. We'll let the oxygen empty out there. And this one, we actually want to go from here up like this, and then we can remove this gas bridge. I think I'm going to have this line empty into this and this into this, because that line seems to be more active. That way those 2 lines can get emptied out there. And we'll cut this off here. There we go. So this oxygen and this oxygen will all get out, and then we can remove those pipes. Same with this line will go there. Anyway, this line here comes up, it goes all the way across, and it feeds oxygen up to the top of the map for us. So we have oxygen and hydrogen ready to go when we're ready for it. Basically, we want to build sections up here in this vacuum area for our liquid hydrogen and our liquid oxygen. So given the fact that we have it right here, I want to build, I'm going to build a liquid lock in order for us to get in, because I want to be able to leave it open while we're doing some testing and working, and then I'll seal it off later. So this is where our liquid oxygen is coming out. I think we can do our lock for this one here, and then up here we'll do another one. Let's actually do it a little bit higher, and then we can feed the line down a little bit. That way we have some space to work. We're going to go and do to here and go across, and we'll come across like this. And that's how we'll build it. That way we have some space in between them. 1, 2, 3, 4, and then we go like that. And that'll be the start of what we're doing. And what we're going to need to do for our liquid lock, I'm going to put down a bottle drainer here, and then another one here, and I'm going to do a pipe that comes down and here, standard thing we have been doing, where we put down a vent, and then we also put down automation so that we have a hydro sensor and an automation wire. That way I don't forget about it. We'll set those pretty low. The only liquid we can use in here, and I also need drywall in the back. Let's do something interesting for the background. I like these little clouds up in the sky. That way the liquid lock doesn't spill out into space. The only liquid we can use for these locks is going to be super coolant, because we're going to be having liquid hydrogen in here, and we're going to have liquid oxygen in here, and that's going to cause it so that if we have any other liquid here, it will freeze up, and we don't want that. So super coolant is heavy enough that it'll sit below liquid hydrogen and liquid oxygen. It's also, it will not freeze no matter how much cold we give at it. So we'll have those locks there so that we can get in and out. And super coolant is pretty expensive, but we're soon going to have more of it than we can really be worried about. So we'll have plenty to go around. I'm going to actually just finish this out and make it a nice square, just because I like it aesthetically speaking. Yeah, we'll be able to build all that. And then that'll give us room in here to work. The process for creating liquid hydrogen and liquid oxygen is pretty much the same. I pump in gas. I have a heat exchanger, which is actually in this case going to be working more as a heat sink to pull the heat out. And it will lower the temperature of the gas until the point where it turns into a liquid. Like I showed you, the oxygen is a lot easier to do than the hydrogen. And because of that, we're gonna use a system that actually has like a heat exchanger similar to what we use in our petroleum boiler. As far as this goes, we'll have a setup where we have tiles that connect to the gas, and then a mechanism that we can close and open that allows us to transfer heat, but only when the temperature is in the target that we want. That way we're only pulling heat out when we're in a target range that's pretty precise, because we want it to be, we do not want to be going off of just using a coolant line, because we can't get down to a really tight window like we need. So we're going to have that set up on this end, and inside here we'll have vents and automation to let the gas in, and then pumps to pump the liquid out, and a few other things like that. But first we just need to get this part built up so that we can get in here and get everything done. So we're gonna do some drywall on the back, and since we're doing oxygen and hydrogen, let's do them. We'll make this one, since this is oxygen, we'll make this with the pastel blue for oxygen, and then we'll use the pink for hydrogen to do the background walls. And then once this is all built, we'll be able to close up the end. We'll get the system to exchange heat all set up for us, and then we will start running piping so that we can actually get this thing working and making liquid hydrogen and liquid oxygen for our system. I've gotten the basic infrastructure in place that we need in order to start this system up. Basically, I have 2 different cooling loops, and I realized afterwards I could probably do this with just 1 loop, because we could just do both of these to the colder of the 2 settings that I need, and then only pull in temp when we need to, because like this is going to be like a heat sink where it's drawing across to this. If we had connected these 2 together, we probably could have just kept them both at absolute 0, but only opened or closed the doors when we needed it on each one. But I'm going to keep them separate for now, just to make sure I can get it as precise as I want. The oxygen, we need to be at a slightly higher temp than the O2. So for liquid oxygen, we need to go down to minus 183 is when it turns to gas. Minus 218.8 is when it turns into solid. So between these 2 numbers is what we're shooting for. And it's a big range. It's 35 degrees, which makes it a lot easier. So I'm going to have it so that we have this set. We're going to make it, let's make this 190 for now. Minus 190. So if the temperature in here is not below minus 190, we'll close these doors, and that'll allow heat to transfer from here. So basically heat from here will get pushed out into here where it gets cooled down by the loop. The hydrogen is going to be a little bit different because the temperatures are different. So when we look at liquid hydrogen, we need to be between 252.2 and 259.2. Remember, there's a 3-degree variance. So when we're cooling it down from a gas, we need to go to 255.2, but we don't want to go past 262.2. So I'm going to shoot for minus 257 to start. And we may adjust those as we go. So those will make it so that these doors will close when we need them to. And now we can connect up our gas lines and start running those in. We don't have any pumps in here. We don't have any of that working yet. I just want to start sending some gas in and seeing if this will work. And I'm going to save it here just in case I run into any trouble where I forgot something. I don't like to do rolling back on saves too often, but when it's something like this where opening it up is going to release a whole bunch of resources into space, and mostly it's going to take a lot of my time to repair, I'm going to go ahead and use that save point to allow us to do that. So liquid hydrogen and liquid oxygen is a system that takes a long time to kind of prime, because you're basically cooling everything down to a really cold temperature. And anytime you introduce more heat, it warms back up, and it just takes a while. We finally reached the point where we're getting a little bit of liquid hydrogen. Liquid oxygen is much faster because the temperatures that are needed are much higher. So we're getting that faster. But what happens is when the gases turn to liquid, it makes more room for more gas to come in. And right now the oxygen is coming in at 57 degrees and the hydrogen is coming in at 44. It's not a big deal that they're coming in hotter. It just means that when it goes in, it increases the overall temperature of the gas in the room, which means it takes longer for it to cool back down again. Once we get everything cooled down, everything in the room has reached a stable temperature, and we're adding it in as we're taking it out, it shouldn't be that bad because it'll already be really cold. So the little bit of heat we're introducing shouldn't affect it too much. But it's going to take a long time to get it all kind of switched over. You can see how it's state changing a lot here. It's because the temperature coming in is heating up some of this, turning it back to gas, and having a larger room like this helps with that. It's a bigger heat sink for that heat to get lost in. I did set up a little bit of a loop here, and it's kind of hard to see because I've condensed it down, but basically it's just a loop that goes between these two bridges, and this bridge is bridging onto that loop. That way when gas is in this line and this pressurizes, it keeps moving like it is up here. That way we don't have any gas sitting there inside the line just getting colder and colder until it cracks a pipe. That's just how that is working. So this temperature keeps getting down closer and closer to the target temperature, and it's lowering the gases here. Hydrogen needs to be at minus 255, and as soon as it does, it drops into the liquid hydrogen. And this needs to be at, I forget what oxygen is off the top of my head. It needs to hit minus 186 to become liquid, and then it drops out. So we have that going here. This is way colder than it needs to be, so this should be going faster. But again, it has more heat to cancel out. So it's going to take some time. We'll let this keep running until we get both of these rooms really, really functioning. So we're getting close with our setup here. The oxygen is doing great. I am now running oxygen through the line into our storage tank. So I went up and looked for, I want to do a trip with this rocket to 130,000 meters, which is our gilded asteroid. That way I can get a large amount of fullerene. I've looked up what I need in order for that to work, and I need to have 1920 coolant and 1920 fuel. So I set the liquid oxidizer tank to 1920, and I set this meter to 1920. So this is going to pump out liquid oxygen until we hit 1920, which will fill this. If for some reason I did the math wrong or I have these numbers off, I have a loop to bring the coolant back and drop it back in here. With it still moving through the lines, it should be fine, keeping its temperature so that it doesn't cause any breaking pipes, hopefully. With our hydrogen, I set the tanks here. These two are both set at 900. This one's set at 139 because I need 1939 for, well, actually, I think I need that for this. Well, because of the extra weight for the extra tank. I'll have to check that again when we're done, but that should fix that. That's what's 1939, and then I can just leave this fuel tank here without having to deconstruct and move everything around. That's the goal. So that should work. The hydrogen, however, we're still slowly building it up. Every time we get to the point where we can let some more in, that hot hydrogen comes in, and because the temperature threshold is so narrow, it causes some of the liquid hydrogen to warm back up, turns into gas, and it takes a little while to cool it down. That will eventually no longer be a problem because we'll have a large enough reserve of this to keep the whole place nice and cool, and that little bit of extra gas we're adding in every time we send liquid out won't be a problem. But because right now we're putting in large amounts of the gas and converting it to liquid, it's a slow process. So I'm going to let this continue filling up the oxidizer to make sure I don't have any problems here. And then I'm going to probably just let this AFK for a little while so that we can produce a large amount of liquid hydrogen. And then when we come back, we'll be able to test it out to see that this pumps, and then we'll send our first hydrogen rocket of this playthrough. So I guess I will see you in a little while once this is done, and then we will hopefully test our rocket.
We don't have to wait quite as long for the hydrogen. We're still waiting for more of it, but it is now steadily climbing up, and the reason for that is I made a small change.
So you can see that there's an extra pipe here, but I'll show you from the start. So we have the hydrogen still comes out, it comes up this way. I now branch it off and it comes over this way to run through our chill room over here to pre-chill the hydrogen down. So it's coming in at 58 degrees. It's coming out at almost minus 100 degrees. Comes up here, and then when it goes in here, there's less increase in temperature for it to balance out with our heat injector here, or our heat sink here. So then any hydrogen that doesn't fit in the room because it overpressurizes would get sent out this way. Right now it's taking most of it back in, but then it comes back down this way and it goes all the way down and back into our hydrogen system back here, where I have it going back around, and it goes here and it hits this bridge priority first. So the pre-chilled air that's returning gets sent first, and then more hydrogen is added into stock it back up, where it goes back around and it loops back up and it repeats. And so eventually this will just cool down to the ambient temperature in this room, which I have set to chill down using this one to minus 200. The time has come. We are ready to launch. Before I do that, I want to show you a few changes I made. I realized having this empty fuel slot was just extra weight for no reason. And then I thought I can send a research module so that while we are here at Gilded Asteroid, we can learn some more things. So if we send a research module, we can learn some more about what things are available in these slots. That'll help us just going forward. Another change I made is I changed this piping up. It's still ceramic. I shortened it with some bridges. That way there's less travel distance for the hydrogen going in. Still getting some breakage. Only thing I can really do at this point, other than getting the hydrogen even cooler, which is tough because there is a very small window for it, is replacing these sections with insulate pipes. So basically insulation made out of insulation. And that will make it so that there is no heat loss and I shouldn't have any breakage. The problem with that is to make insulation, I need, or to make insulate, I need isosap, abyssalite and reed fiber. Abyssalite and reed fiber are not a problem. Isosap is. So the only source of isosap I have at the moment is on this asteroid right here. So I redirected one of my petroleum rockets there. It's only 6% though. So that's more than what we were getting from the fullerene, but it is still a very small amount each trip. So we're going to get some of it. We'll make some insulate, but we need to make insulated pipe. We need 400 kilograms each time, and this recipe only makes 100 kilograms. So I believe this takes 20 kilograms of isosap for each one. We'll see. I don't know the recipe because it's still undiscovered. That will be very hard to make long pipe runs like that, but I can probably get enough after several trips to just make this section and make this work. But for now, we have this working. So we're going to launch this and have it go to our Gilded Asteroid for the first time. So this will be our first hydrogen rocket launch. The other change I made is I added in a temp shift plate. That is, I think, vital, and I forgot to put it in. Basically, I had one here, and this covers the 8 tiles surrounding it plus itself. So 9 tiles, it distributes the temperature. Well, this one not being here meant this was cooling down just these tiles here, and then it was picking up that chill and moving it down. So it was doing it slowly. This one means I can take the temperature from here and directly transfer it to all the tiles around it, which means this temp shift plate is picking up that temperature and it's going the whole way down. So all the way down to this pump, we are evening out the temperature inside this room with this plate, meaning that the cool is transferring through much more quickly and we are building up more hydrogen even faster. So it's going up a pretty decent amount now. With that combined with the fact that my hydrogen gas is coming in at minus 100 is also helping a lot. So we want to, I think we already disabled the auto repair on these things so we can mark them as suppressed so we don't see those messages, and we'll be good with those gantry just the way they are. They do their job even when they're broken, which is fine. So in the future, what we're going to be working on is getting another rocket set up, working on getting more improved piping so that we can actually transfer the fuel without losing any of it, because right now, and whenever I transfer hydrogen gas, I lose some. And as hard as this stuff is to make, I don't really want to be losing it. Getting it filled up and again continuing to chill it down farther will also help with that. But I think having better piping is the best way to go. An alternative we could do is use the trick where if we send out 1/10 of the pipe's amount, then it would not break. But the problem with that is that the tanks, even if I'm filling up 1 pump per tank, that's 900 kilograms per tank. And so at 900 kilograms at 1 kilogram per second, that means it's going to take 15 minutes at a minimum to fill up the fuel in each of our rockets, which wouldn't be terrible, but it wouldn't be great either. So, we're looking at having, several cycles for each rocket to refuel, and we don't really want that. So we're going to keep working on it, come up with better solutions so that we can continue forward with that. But it's probably just going to take us sending rockets out several times so that we can get the materials that we need. Now we have damage in here. Oh, it's probably because it pumped up just to get to this thing, and that's sitting in the pipe, and it's not happy about it. Getting the pipes all cooled down and getting the whole area cooled down will also help with that. So we'll get there. But for now, we're going to let our rockets go and do their thing, collect the resources we need. We'll probably collect several trips between episodes. And in the next episode, we'll focus on improving this even more so we can tackle all of those space destinations we need to go to finish out our achievements. I hope you enjoyed watching this episode. We'll see you in the next one. Bye-bye.